Hello everyone, myself Meera Khandekar along with co-authors Professor S.G. Agashe and Raunak Pawar. We are from Department of Instrumentation and Control, College of Engineering, Pune. We are here to present our paper Solid Waste Management using Machine Learning Algorithm for Smart Cities for International Conference on Recent Trends in Machine Learning, IoT, Smart Cities and Applications, March 2022. Outline of presentation is introduction to the topic, objectives for the work, types of solid waste, case study, machine learning model, result, conclusion and references. City waste management is becoming challenging day to day due to variety of waste and quantity of waste generated. 95% of food production depends on soil pollution reduces food security by reducing crop yields due to toxic level of contaminants. Less than 1% of Earth's fresh water is actually accessible to us. Nearly half of our rivers, streams and more than one-third of our lakes are polluted and unfit for swimming, fishing and drinking. This improper waste management is directly affecting environment and human life. Day by day, air pollution, water pollution, and sound pollution is increasing due to urbanization. It is reported that in 1950s, only about 30% of the world population lived in cities. By 2014, the level of global urbanization has reached up to 54%. According to United Nations report, by 2050, the proportion of urbanization around the world will reach up to 66%. So this picture shows the municipal dumping landfills. So it is so you can see there are variety of solid waste without segregation is dumped into the ground. So it is time to think what can be done with solid waste management in big cities. It is important to know quantity of solid waste generated per day in this big city. It is important to know type of waste generated per day. To know the quantity of waste and type of waste generated per day in a particular area, we have decided to carry out a case study. So these are the objectives of the paperwork. Study types of waste and processing techniques. Understand how much solid waste is generated per day for Pimpri-Chinchwad Municipal Corporation. Apply data analytics for prediction of quantity of waste generated per day, predict quantity of various types of solid waste for upcoming years. Biomedical waste. Every big city has around 20 to 30 hospitals. Significant amount of biomedical waste is generated per day. We need to handle biomedical waste separately and safely with separate transport system. Biomedical Waste Management Rule 1980 stated that every organization generating biomedical waste are accountable for ensuring that all biomedical waste is segregated, transported, processed and disposed of without any adverse effect to human health and the environment. Biodegradable waste. Any municipal corporation has nearly 20 vegetable markets, around 40 big temples and around 50 hotels are giving service to the society in the big city area. A dedicated transport system can be used for effective collection of waste from temples, vegetables and market and hotels so that waste processing can be done. Composting and vericompost process can be successfully used for biodegradable waste management. Composting is a process where organic solid waste is rotten under controlled condition. The final product is called compost. It looks like in consistency and order and may be used as a soil conditioner. For day-to-day activities, we are dependent on computers, television, printers, stereos, copiers, fax machines. Every household have many electronic appliances like laptops, mobile, charging, batteries, Electronic waste contains toxic components such as mercury, lead, cadmium, barium, lithium. Improperly disposed electronics in landfill release toxic chemical affecting the earth, air, water, soil, and ultimately human health. There should be e-waste collection drives for housing societies so that e-waste processing will be more systematic and effective. Plastic waste is accumulation of plastic objects into the environment and adversely affect wildlife, wild habitat, and human. Plastic waste collection, treatment, and disposal process must be defined by local authorities. Authorities must make sure all the defined process must be practiced in day-to-day life. There should be plastic waste collection drive for housing societies so that plastic waste processing will be more systematic and efficient. Through pyrolysis, we can handle wide variety of plastic forms. Shredded plastic is stored in reactor. After that, catalyst is applied and plastic is heated up to 150°F. The released gases such as methane and propane are stored in separate gas tank and used as a source of heat for the system to operate. As per Central Pollution Control Board and National Environment Engineering Research Institute, solid waste collected by corporation follows distribution percentage as given in the graph. Around 47.5% waste is biodegradable waste, 8.1% is paper waste, 9.2% is plastic waste, 0.5 is metal waste, 1% is of glass waste, and 33.5% include other waste. With this information, we have decided to carry out a case study for Pimpri-Chinchwad Municipal Corporation. Data like total number of zones A to H, different wards under particular zone, number of household in a ward, door-to-door collection status of garbage from the households. All this data available on PCMC portal. For solid waste collection, different types of community bins, compactor bins and dullos are provided for residential areas. For effective collection of waste, it is important to understand what type of waste are generated in city area. In addition to that, we can have segregation of type of waste like biodegradable, metal, plastic, paper, etc. Sample data like total number of zone A to H. So under zone A, there are total 4 wards, 10, 14, 15 and 19 wards come under zone A. Number of households from a particular ward are available. So ward 10 include 18,521 households. Door-to-door collection status of the garbage from around 17,924 houses. Out of 17,924, 14,339 houses segregate the waste before deposits. Likewise, we can collect around 33 tons per day solid waste from ward number 10, which come under zone A. For ward number 10, total 43 street bins have been provided. Ward number 14, which again come under zone A, include 18,910 households. Out of 18,910 households, for 16,106 households, it is possible to collect the garbage. Out of 16,106, 12,884 households segregate the waste before deposit. Likewise, 29 ton per day waste is collected from ward number 14, which come under zone A. For ward number 15, around 20,567 households are included. 17,500 for 17,500 household, it is possible to collect garbage. 14,000 households segregate the waste before deposit, and around 32 tons of solid waste is collected from ward number 15, which come under zone A. So this data is available on PCMC on PCMC portal, and we have considered like number of households and solid waste generated per day. So these two parameters are very important for us, and we have considered these parameters to develop the regression model. So based on the data, we develop the linear regression machine learning model for prediction of quantity of solid waste generated per day. So to develop the linear regression model, we have used Jupyter Notebook platform. Uh, so if a specific PCMC ward include like 35,000 or 40,000 or 45,000 number of households, so how much amount of waste will be generated? So this information is very important to know, and that's why we have decided to predict the quantity of waste for number of households. R square and adjusted R values are observed to know the how good is the regression model. So, and then sum of square, mean squared error and root mean squared error. So these values tell us like how performance of the developed model. So these are the observed values after building the model. So we have used same model to predict the solid waste um, uh, uh, generated per day. So these are the results. So for 35,000 number of households, predicted solid waste is 53.23 ton per day. If number of houses increases from 35,000 to 40,000, then solid waste generated would be for 59.91 tons per day. As per the we have percentage distribution of solid waste um, as per the report shared by Central Pollution Control Board and NERI. So using same table, further we can segregate how much biodegradable waste is generated per day, how much paper waste is generated per day, and plastic waste is generated per day. So for 35,000 number of households, total waste generated is 53.23, and out of 53.23, 25.23 ton of biodegradable waste is generated, 4.31 ton paper waste is generated per day, 4.9 tons per day plastic waste is generated. Similarly, for 40,000, total solid waste generated is 59.91 tons per day. Out of that, 28.4 is biodegradable waste, 4.85 ton is paper waste, 5.51 is a plastic waste. For 45,000 household, 66.59 tons solid waste is generated per day. So out of that, 31.56 is a biodegradable, 5.39 ton is a paper waste, and 6.13 ton is a plastic waste. So once we understand what type of waste is generating, so that we can use proper processing technique so that we can dispose the waste effectively and systematically. So conclusion for the paper is like for systematic and effective waste management, it is important to know the quantity of waste generated in a particular area, Prediction for quantity of solid waste generated per day can be available using developed regression model. In addition to that, we can have distribution for various types of waste like biodegradable, metal, plastic, paper waste, etc. Once we understand the total generated waste, we can use proper technology for processing the waste. We are thankful to Pimpri-Chinchwad Municipal Corporation to make available the data for solid waste management. These are the references which we have used to carry out the work. Thank you. We are thankful to the organizer for giving us the opportunity to present our paper for international conference on recent trends in machine learning, IoT, smart cities and applications, March 2022. Thank you.